In this video, let us solve problems based on Pythagoras theorem. So here we've got a question which reads like this. A right triangle has a hypotenuse of length p centimeters and one side of length q centimeter. If p minus q equals 1, find the length of the third side of the triangle. Let the side that we have to find, let the length of the side that we have to find, the third side, let the length of that side be x centimeters. Let the third side be x centimeter. So then, by Pythagoras theorem, we have p square equals q square plus x square. Why is this? Because we know that the theorem states that hypotenuse square equal to the sum of the square of the other two sides. So a right triangle has hypotenuse of length p centimeters. So the hypotenuse is p centimeter and one side of the other two sides is q centimeters. So therefore the hypotenuse square equals the sum of the square of the other two sides. So hypotenuse is p, so therefore it's p square, equals another side is q, therefore it's q square, plus the third side is unknown, so we've taken it as x and therefore it becomes x square. This is the equation that we've arrived at. So now we need to find x, right? So let us take x to the left hand side. So x squared equals p square minus q square. Now x square equals p square minus q square is of the form a square minus b square, which is a plus b into a minus b. So let me write p square minus q square as p plus q into p minus q, right? So now it's already given that p minus q is 1, right? So x squared equals p plus q into p minus q is 1. So that is nothing but x squared equals p plus q. So another thing is, now since p minus q equals 1, we can write p as 1 plus q, right? The q goes to the right hand side, becomes 1 plus q. So here let's replace p by 1 plus q, then x squared becomes 2q plus 1. So if x squared is 2q plus 1, x equals square root of 2q plus 1. So here we have. So the length of the third side, that is x, equals a root of 2q plus 1 centimeter. This is what we needed, and we've got it. This is a very basic and a very, very simple fundamental problem based on Pythagoras theorem. So there's nothing much in it. There's not even much to think. You know, you've got the hypotenuse, and then you've got one of the other two sides, and then you need to find the third side, and then you've got another extra data as well. So use this and do as much as you can to reduce the variables concerned. So here we've taken out p and we have like come to q. So this is going to be much easier. If at all, you know, you've got the value for q and then you have to find the actual length of the third side, you can use this. But anyways, as far as the Pythagoras theorem is concerned, an application of it, this was a pretty simple problem. Let's solve another problem. So here we have another question. A man goes 10 meters due east and then 24 meters due north. Find the distance from the starting point. Let's draw a xy coordinate, and let's say the man is right here in the center. The first thing is he goes 10 meters due east, right? So we've got, you know, south, north, and then we've got east, west. So this man goes 10 meters due east, and then he goes 24 meters due north, and then he goes 24 meters due north. So this is 24 meters and this is 10 meters. So we need to find the distance from the starting point. So find the distance, find this distance. So now what happens is this has become a right angle triangle, right? You've got a hypotenuse here and then you've got other two sides. So it's pretty simple. Let's say name this O, this is A, and this is B. This is a very, very simple basic problem. So here the hypotenuse is OA, so it is OA square equals the sum of the square of the other two sides. The other two sides are OB square plus AB square. So it is nothing but we are following the Pythagoras theorem again. Pythagoras theorem states that in a right angle triangle, the hypotenuse square or the longest side squared equal to the sum of the square of the other two sides. The longest is the hypotenuse. So let's see what it measures. So we've got OA square, and then OB square is 10 meters, so that is 10 square, plus AB square is 24, so 24 square. So we've got OA square equals 100, plus 24 square is 576. So we've got OA square as 100 plus 576 is 676, and OA is square root of 676. So the square root of 676 is equal to 26 meters. So the distance from the starting point is 26 meters. Apart from the problem, if you see, this is also the shortest distance between two given points, because he travels at 10 meters due east and then 24 meters due north. So that is 10 plus 24, which is 34 meters. But he could have saved 8 meters if you'd have, straight away traveled from O to A in this path. So that's 26 meters. So this is another very basic and a fundamental and a simple application of the Pythagoras theorem. And I'll see you in the forthcoming videos with more advanced level problems based on Pythagoras theorem.